closures and lambdas. One of the features that Kotlin adds, but Java now has also added, and many languages are adding it if they haven't already, is the idea of lambdas. And lambdas are partly from the idea of first-class functions. So in Kotlin, functions are mostly first class. It's not a fully functional language, but you basically can treat functions as types and values. There's a function type, there's a function value. A function type is basically its interface. What are its parameters? What does it return? The name doesn't matter, but you want to be able to say, okay, I need a function here that has these parameters and these return types. When you have that, it becomes first class. And if you can then say, okay, I want to have a first class function, you may want to be able to say, I need to give it a name, have a function name. But sometimes when you need a function only in one place, it is nice to be able to have a function literal. Like you can just put a number in your code rather than having to define a constant that has that number and then use it. By the way, that constant can be really important because random numbers become very hard to understand what they mean. But if you had to do that for text messages in, say, an error into an exception, you don't really want to have it have to be a constant all the time just to define it and only use it in that other place. But if you use numbers that have a particular meaning, a constant allows you to give it a name that makes what is going on much more understandable. Anyway, you can have a literal function. How do you do that? Well, you call this operator, or function, which is a lambda that takes its parameters and makes it into a function. And it returns that function as a value that you can then assign to any variable or storage location, so parameter, attribute, etc. Local. And when you have the ability to do that, you can do some quite powerful programming things. In particular, certain kind of problems become much easier to express, much more concise to express. So a lambda is a function that creates a function. Effectively, it's a syntax for creating inline functions. In many languages, including Kotlin, what is created actually is not so much a function as something called a closure. The difference between a function and a closure is that a closure allows you to capture values out of the context in which the lambda function was called. So you're basically allowed to put data with this function and packaging it up together, and when it's called, that data is available to the implementation of that lambda function. Whereas you have a pure function, it can only work on its parameters and have a return value. The closure can have reference to the parameters it was given. So Kotlin creates something called a closure. It closes in those values, it captures them. There's one limitation to working on the JVM or the Android runtime, that it doesn't do. So normally inlining functions, so taking your code of your function and putting it inside the caller, so the callee's code is just copied into the caller, so that you don't need the jumping into that function going back. That is normally done by not done by the compiler on JVM language, but by the virtual machine runtime, the Java virtual machine or the Android runtime, because they have more knowledge to be able to do that. And if you don't do the inlining by hand, they can actually decide whether or not it's a good idea, because sometimes it isn't. And the more you know about the execution context, the better you can optimize. Disadvantage, of course, is that if you are very close to the execution context, you might have a user waiting for you to do the optimization. That is the ahead of time or just in time compilation dichotomy. In any case, there are some cases where we know that inlining really needs to be done by the compiler. And in particular, there are some features that Kotlin can have because it does compiler level inlining. So two of them in particular are the non-local returns. So you can basically, inside your Lambda block, you can have a return, and that return returns from the function that called the Lambda or created the Lambda. And that's a very powerful construct, but that means that the function that, if you have a function that takes the Lambda parameter and then that Lambda parameter returns through that function to the function that was calling this function, and that's like what your run and your let and your apply, etc. do. You basically pass through that function. To make that work, you need to be able to basically go into the guts of that function. And if it's an inline one, that function just disappears, and the outer function, the one that you want to actually return from, contains the code of the thing, and then the Lambda also gets inlined. And as such, you just don't have any function calls left over, and non-local returns actually work. And the advantage there is that it can allow you to make your code look like a control structure. And it's a very powerful thing to be able to do. And Kotlin uses that heavily, because you can create your own control structures like the use. So in Java, you have the try with resources concept, where if you once you finish that block, it will automatically close your file. In Kotlin, you can actually do that at library level with the use function. You can implement your own one and make it work exactly the same. Do this wrapping behavior and automatic closing behavior, but without having to have language support for that, a specific language support. Another part where inlining is needed is if you want to do reified type parameters. Basically, as you probably know, JVM uses type erasure, but the compiler knows the types. And if you have a function that is inline, you can say, okay, this is the type parameter, make it explicit, allow me to reference this inside this inline, because inlining happens during compilation, so the type has not been erased yet. You can access that type and do whatever you want with it, including getting the class object belonging to that. So you can do a little bit of poor man's reification. Look at that lecture if you for more information on that. So there are some common functions in Kotlin that you probably want to know: run, apply, with, let, also, and the use one. The use is the one that I just talked about, which does automatic closing on completion. But it also helps to understand the concept. So I will not ask you to exactly what does which one do, but you want to have a look at how they work. So this is, for example, how run works. So run function takes a Lambda parameter. So the curly here defines Lambda. Let's see. So this curly here defines the Lambda, and we print our line. So this calls print line, and it returns. And then there's the 7. This is the last expression. So a Lambda will actually, the value of the Lambda will be the value of the last element, unless it has sufficient type information to know that it is unit, in which case the return of the Lambda might be unit. In this case, so the value of x becomes 7 here, and it prints 7 as well. So, and this particular run does not necessarily take a receiver. You can have it. It might have the receiver, which is the an outer class in which context it lives.